In a world drowning in raw data, how do we extract meaning without going under? Enter Pandas, the data wrangler's trusted companion. With Pandas, you can slice, dice, and transform your data in ways you never thought possible. Or maybe you have. I'm not you. Time to put Pandas to work. In the year 1985, Microsoft created Excel, believing they had mastered data manipulation. They were incorrect. Pandas emerged in 2008, born in the data trenches of a quant finance firm, to transform data manipulation from medieval spreadsheet drudgery into concise Pythonic code. Consider Pandas as Excel evolved, no longer bound by cells and formulas, but enhanced with the full computational power of Python. You will not drag. You will not click. You will write code that bends data to your will. Now that you understand why Pandas exist, let us examine its core components. There are two fundamental data structures you must understand: series and DataFrames. A series is a one-dimensional array with built-in indexing and additional capabilities. Think of it as a single column of data where each value has a label, what we call an index. To create a series, supply the data, the optional indexes, and the series name. Run. Unlike primitive arrays, a series is self-aware, capable of carrying both data and its organization. A data frame is a structured array of data in which each column is a series, and all series share the same indexes. In essence, a data frame is like a spreadsheet supercharged by Python's computational power. Remember, all data frames are collections of series, but not all series need to evolve into data frames. Sometimes one dimension is sufficient. And now that we understand these structures, we can begin to manipulate them. Now for the deeper details on series. Import Pandas. If import fails, then install using pip. How was the weather? Is something you might say to a time traveler if you wanted to make polite conversation. Let us create our first series using readings from a standard Earth week. Run. Notice the automatic indexing system, a Pandas feature that assigns numeric labels starting at 0 by default. While functional, it lacks context. We can enhance this series with temporal coordinates, what humans call days of the week. This transforms our data from mere numbers into meaningful measurements anchored in time. Run. The benefits are immediate. Instead of querying position 3, we can extract data using meaningful labels like Wednesday. These readings are in Fahrenheit, a temperature scale that 94.6% of Earth's population does not use. Let us convert this data to Celsius, the arguably more rational choice. The conversion protocol is straightforward. Subtract 32 and divide by 1.8. These operations will apply to all data in the series. Observe. Note the transformation of our data type from integer to float to avoid rounding for our precise Celsius values. Now that we understand the one-dimensional series, let us advance into 2 dimensions with the data frame. Consider a scenario from human resource management. The data involves agents, known as employees, each with multiple attributes requiring synchronized storage. Let us create a data frame from our data dictionary. Run. What began as a simple dictionary is now an organized matrix of information. Each column exists as a series, working together in a synchronized structure. The power of a data frame lies in its efficient data manipulation capabilities. We shall demonstrate. First, we can extract any column as a series by column name. There are 2 ways to do this. The first, using bracket notation, is more versatile. The second is dot notation, which is more concise but only works for column names that are valid Python identifiers. Run. Both methods achieve the same result. Choose the one that fits your needs. Additionally, or alternatively, we can filter our data using mathematical conditions. For instance, identifying employees whose compensation exceeds the arbitrary threshold of 75,000 credits. Run. Now we can perform statistical analysis on an entire column. Such efficiency. Run. Observe the calculation of average compensation. These examples are just the beginning of what DataFrames can achieve. In the digital world, data typically lives in files and databases. Pandas provides straightforward methods to load data from various formats: CSV, Excel, JSON, and more. Let us examine a real-world scenario. Shareholder voting data from Quantum Horizons, a private space exploration company. The data resides in shareholders.csv. To transform this CSV file into a data frame, we use the readCSV function. Run. Did it work? Let us check using Pandas' sophisticated inspection tools. The head method reveals the first 5 rows. You may adjust this window of observation by specifying a different number of rows. On the other end, tail shows us the final entries. For a more analytical perspective, info provides a systematic overview of our data frame. Run. We see the number of non-null entries in each column, data types, and even memory usage. Excellent info. And for useful stats, the describe method is your friend. Run. Who knows? Maybe these stats will influence Quantum Horizons' next strategic move. Now that our shareholder data is available in a data frame, we can now do stuff with it. The square bracket operator provides our first method of data access. When we specify a column name, Pandas returns a series, our familiar one-dimensional structure. Run. For multiple columns, we simply provide a list of names within the square brackets. This creates a new data frame, a subset of our original. Run. But what of finding specific shareholders? For this, we use boolean masks, filters that identify rows that meet certain criteria. For instance, let us select all shareholders with more than 10,000 shares. Run. We can construct more complex queries by combining conditions. Observe, as we identify shareholders who support both the Mars base and the Space Hotel, our most enthusiastic investors. With these selection tools at our command, we can now proceed to modify our DataFrames structure. DataFrames are not read-only objects. They are adaptable. We can enhance our shareholder analysis by calculating new metrics and removing obsolete ones. Let us first calculate each investor's voting power, their percentage of total shares. This requires both arithmetic and assignment. First, we compute the total number of shares. To create a new column, simply assign data to this column. For the voting power, we divide the number of shares by the total number of shares and format it nicely. Run. Notice how Pandas performs the calculation across all rows simultaneously. Most efficient. DataFrames allow us to create new columns based on conditional logic. For instance, we can classify investors by their level of influence. Using the lock method, we filter rows for specific conditions and update the investor class column. For example, we assign strategic to shareholders with 10,000 or more shares. Run. New column complete. Sometimes, data requires removal. The drop function eliminates columns by name. Observe. A warning. By default, drop creates a new data frame. A considerate safeguard. If you wish to modify the existing one, you must specify in place equals true. The choice between mutation and creation is yours. Now that we have optimized our DataFrames structure, we can address the curious case of missing data. Let us examine two distinct scenarios in our shareholder data. explicit abstentions versus missing responses. These are not the same thing. When a shareholder actively chooses not to vote, they submit an abstain, a deliberate declaration of neutrality. If a ballot is not returned, we have true missing data. This is represented in Pandas as NaN, or not a number. Let us first identify where we have actual missing data. Run. Pandas provides multiple strategies for handling these gaps. We can fill them with a default value like no response. Run. We can remove rows with missing data entirely, though this dramatic step eliminates partially completed ballots. Run. Or we can analyze the data while explicitly accounting for missing values. Here, we count all unique responses, including NaN, which represents ballots that were not returned. Run. Now that we have ways to handle missing data, we are ready to analyze voting results. Pandas provides powerful tools for data aggregation, a process humans might call getting the big picture. Let us begin with basic vote counting. How many shareholders support each proposal? Run. Next, we analyze the interaction between votes for both proposals using a cross-tabulation. This reveals patterns such as who supports one project while opposing the other. Run. We can also examine voting patterns by investor class. Do strategic investors vote differently than minor shareholders? To do this, we group the data by investor class and calculate total shares, as well as vote distributions for each class. Run. Finally, we weight the votes by share percentage, creating a hierarchy of influence, democracy adjusted for capitalism. These aggregations uncover patterns that may determine the future of our Mars colonization efforts. Run. After our rigorous analysis, we must now preserve our enhanced data for future reference. Pandas offers multiple protocols for data export, mirroring its import capabilities. The most universal format remains CSV. Observe the basic export operation. Run. The file now exists. The new columns are there. However, we may wish to export only our processed data, the analysis that reveals voting patterns weighted by shareholder influence. For this, we shall create a focused export. Run. Excel files offer another common export format, with the advantage of preserving multiple analysis sheets in a single file. Your choice of export format should align with your future data requirements. CSV files offer simplicity and universal compatibility. Excel files maintain formatting and support multiple tables. The decision is yours. Remember to verify your exported files. Trust, but validate. Run. Well done. You have tamed the wild beast that is data with the help of Pandas. No longer are you a mere bystander to the data deluge. You are now a seasoned navigator, charting courses through seas of information. Remember, in the quest for knowledge, clean and well-structured data is half the battle.